Hi everyone. So for today's lecture, we will discuss the state space representation. Basically, we have the two approaches for solving for any system. So one was the conventional method, and the second one is the state space representation. So if we are talking about the state space representation, it has the various advantage over the conventional methods. The basically, if you are going for the transfer function approach for representation of any system, so there are limitations like initial condition we cannot consider, and we have to assume the initial condition 0, and that is also applicable for the single input and single output system. And if we are talking about the state space representation, so it is very adaptable for the various system, as it has major advantage over the conventional method, like it has used for the multiple input multiple output system. It may be used for the linear non-linear system. We can also consider the initial condition. So in the today's lecture we will see that how can a system can be represented into differential equation form to the state space representation. For understanding that topic, I am considering here an example in which a differential system, we can say the system can be represented in terms of differential equation. So the system is given to us is like in the terms of differential equation d cube by dt cube plus 3d square by dt square plus 4x equals to the input signals are given, and correspondingly the output equations given. And we know that for state space representation, the generalized equation we can write as x dot equals to ax plus b and y equals to cx plus d. So we will represent in the terms of this form. So this is called our state equation, and this is our output equation. Now the question is, as we know that this is the higher differential equation, so one of major advantage of state space representation is also that we will solve any higher differential equation in the terms of single order differential equation. So the solution of single order differential equation is much easier as compared to the higher differential equation. So ultimately we are converting these higher differential equation in the terms of single order differential equation, that is basically state space representation. So for that purpose we will start here. So we can see that this we will define the variables here. First of all, we will define the variables. So we know that the order of this differential equation is 3. So what we will do, we will start from here. So we can represent here x equals to x1 and x1 dot equals to x2, x2 dot equals to x3. So why I am representing here? Because if I am talking about here, so x1 dot we can write here what? Dx by dt, dx1 by dt. So we can also represent dx1 by dt, and similarly we can write here in the terms of d square by x by dt square, and similarly d square x by dt cube. So what we will do? We can define here, and we will stop here. We call x3. So third dot is here, so x3 dot equals to, we can represent here the further system, like we will write here the same equation in the terms of right hand side. So what we can write, if I am talking about the x3 dot, it will be d cube x by dt cube, right? So we can write, and we will take here in the right hand side. So what we will get, 3d square x by dt square it will be minus 4d by dt x minus 4x, and all these three will be u1. I am writing here only u1 plus 3 u2 plus 4 u3, like this. So what we will do here, we will represent all these differential equations in the terms of state variable. So what we will do, x1, if I am talking about the x, I am representing here the x1. If I am talking about dx by dt, it means what? This x1 dot equals to x2. So we can represent here likewise. So it will be d square x by dt square. So basically this is the x3. So what we will write here? We can represent here like in the terms of differential equation. So what we will get? If I am writing from here this side. So minus 4x1 we are going to like this, in this way. So what we will do? Minus 4x2 and again minus 3x3, and all this input will be same, like u1 plus 3u2 plus 4u3. Now the question is, what we will do again? So we will represent in the terms of differential equation. So for that purpose I am going to write here. Again I will write a letter. So just going to present here. The three variables are there. So we will write here x1 dot, x2 dot, x3 dot, like this. And we will fill the matrix data. So it will be in the terms of x1, x2, x3. And again the matrix will be, we will fill later, and it will be u1, u2. So what we will do here? If you are talking about the x1 dot, so what is the x1 dot? x1 dot equals to x2. So x1 dot equals to x2. So then it will be looks like 0, 1, 0. So it will be 0 x1, x2 plus 0 x3. So it will be what? This will be x2. And again x2 dot equals to x3. So it will be 0, 0, 1. Now if I am talking about the x3 dot, what will we get here? Minus 4x1, so it will be minus 4, minus 4x2, minus 4, minus 3x3. So these parameters are shifted to here. Now what we will do for the input side? So for the input is only related to x3 dot, so all input for these two will be 0. So here we can write 0, 0, 0, 0, 0, 0. And for that, what we can do, we are need to write here u1, so 1, 3 u2 equals to 3 will be here, and 4 here. So this is the your state equation, x dot equals to ax plus bu. Now we will move for the output equation. So the output equation was, our output equation was y1 equals to the output equation of 4 dx by dt plus 3 du1, right? And the y2 was our d square xt, d square x by dt square plus 4 u2 plus u2. So again what we will do? We will again replace these output variables in the terms of state variables. So if I am looking for the y1 dx by dt, so basically it was a x2. So we can represent here like 4x2 plus 3 u1. Similarly, if I am going for writing this y2 equation, it will be looks like d square x2 by, so it will be x3, right? So here we can write here x3 plus 4u2 plus u2. So if I am going to write the output equation, what will be? y1 and y2 equals to, you will see in the matrix later. So what we will get here? In the terms of x1, x2. So obviously x1, x2, x3. Now the plus, if I am talking about the input signal, so it will be, looks like, and again it will be u1, u2 and u1. So what is the y1? Y1 is the 4x2. So the second term input is here, so we can write 0, 4, 0, and u1 term is here. So what we will do here? We will place here like 3 is there, so 3, 0, 0, because u2 and u3 is not present here. So again for the y2, what will the equation of x3? So what we will do? Go for the x3 element, so it will be 0, 0, 3, and the input is what? 4 and u3. So what we will do? u1 is 0 here, and 4 is there, and 1 is there. So this is your output equation. So we can compare here x dot equals to ax plus b. So A matrix is given here, right? So basically A matrix, and this is your B matrix. Similarly for this is C matrix, and this is the D matrix. So we can say that any differential equation can be easily converted into state space representation. So thank you for today. We will discuss the several example for the next lecture. Thank you.